Okay, we're back for another lesson. Um, so let's do some more maths, or if you kind of skipped the ones from last week because you were still getting set up, let's do our first lesson for the term. Hopefully you're all on the right page at this point and keeping up with the work on the Google Classroom. I've pulled my hoodie up over my head just to change things up a bit, but also as a tribute to one of my favorite Year 9 math students. You know who you are. So let's get into it. What I've got for you here is basically the sentence from the government in the curriculum that tells me that I have to teach you this stuff. So if you're wondering why you're learning it, it's because on a website somewhere called the Victorian Curriculum, I am told that you guys need to learn how to apply index laws to numerical expressions and apply index laws to variables. So essentially what that means is you've got to learn how powers work, and you've got to know how to use powers with numbers, but also with letters as well. So we start with the first couple of index laws. You were taught them last year. You've forgotten them. We'll do them again. To be successful today, you will use multiplication, and you'll be putting together terms or expressions with powers in them, and you'll be using division to do the same thing. So let's get into it. So the main thing you have to know when you are working with powers is what they actually represent and what they do. And the one thing you're not allowed to do is write down that this is 15, okay? This is not 15, all right? If you say it's 15, you are wrong. It's bad, 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 bad. Writing down 15 as the answer to that is the one thing that you're not allowed to do, okay? Because if I wanted you to go 5 times 3, I have a really easy way of writing down 5 times 3. I could just write down 5 times 3. We need to remember that what a power does is it represents a shortcut for when I want to multiply the same thing, the same base, over and over and over again by itself. So we have to remember that a power is a shortcut for doing stuff like this. This is really 5 times another 5, and I stop because how many 5s did I just write? I wrote 3 of them. Okay, that's what that 3 represents. It's the same base multiplied repeatedly. So 5 to the power of 3 is not 15, it is 125. Okay, with that said, let's get on to the simplifying aspect of this. So to help you understand these powers, we're going to be taking you through one by one these things called index laws. Remember, an index is another name for a power, and a law is just something that you have to do. Okay, so we're learning what you have to do with powers in different situations. So index law 1, just because it's the first one that you learn every time you do it, because it's the easiest, is when you've got two terms that have the same base. Okay, that's the big number at the bottom, and there are powers on both of them, and you're multiplying these two terms together. So understanding this, it's really easy if you remember what a power actually does. So let's rewrite these two different terms. 2 squared really is a shortcut for 2 times 2. And 2 cubed, again, is a shortcut, and it's a shortcut for 2 times 2 times 2. And then what we have in the middle of these two terms is a multiplication sign, so let's put that in there as well. Let's drop that down in between this one and that one. Okay, and let's just remember that a power is telling me how many times the same thing is being times by itself. So if we look at what we've got now in this kind of expanded form, we've got a whole bunch of 2's all being multiplied together. There's lots and lots of them. And this is a horrible, nasty, long way of writing something out. So what we want to do is simplify it or write the shortcut. I have the number 2 being multiplied by itself 5 times. So I put the power of 5 there. Okay, so what you're doing with index law 1 is you're turning these two terms into this one here. All right, this is some working out in between to kind of highlight it for you, but really you just want to be putting these two things together like that, and you might see what has happened to turn this and to turn that into this here. But let's save it for the next slide, which is the one that's going in your glossary. So because the index laws are such a big part of all the algebra that we learn, not just this year, but all the way almost through to year 12, depending on which maths you study, we do expect that as you build your glossary, you are writing down the definition of each of these index laws and putting down an example. So I'm going to add an example down here, and you should copy this entire slide into your glossary under a big heading of index laws, because you'll end up with 6 of them by the time we're done this week. So you might have seen from the previous slide that I had 2 to the power of 2 and 2 to the power of 3. And that ended up being 2 to the power of 5 when they got times together. So the shortcut for that, you might have noticed, is that I can just add 2 and 3 to get 5. So in words, The definition of index law 1 is that when I am multiplying two terms, they have to have the same base. It can be a number or a variable, so I'll give you one of each. All you have to do when they're being multiplied is add their powers together, because a power is a shortcut for something being times by itself, right? 2 to the power of 3 is 2 times 2 times 2. So if I'm timesing even more 2's into it, I've just got more of them. So if I add these powers together, it tells me how many 2's there were in total. Okay, so a couple of examples of that. Let's just have the number 3. Let's see, to power of 4. And we're timesing some more 3's in there, right? So this is already 3 times 3 times 3 times 3. And we'll just put some more there. Okay, so I've got 3 times 3 times 3 times 3. I've got 3 times 3 times 3. All up, there's 4 3's in this lot of timesing. There's 3 3's in this lot. That is 7, really, because I've just gone 3 plus 4. And the same thing's going to happen when we start working with our variables. So if I have the letter A to the power of 6, that is a shortcut for going A times A times A times A times A times A. And let's just times it by this. All right, times A. And I have not put a power on that one. That means there's just one of them. So the shortcut is that I just add the powers together. So if I want to just write an in-between step to really highlight that, I've got 6 of them in the first term. I've got 1 of them in the second. So this just ends up being a to the power of 7, right? I'm just adding together how many a's here and how many a's there. And because I've got a power there, they're all being multiplied, all right? In your glossary, because you'll need to refer back to it over the coming weeks, months, years. Now that we've got that first one squared away, we'll learn the second index law, which is the opposite of the first one. It involves having a divided by in between a couple of terms. So you'll get the definition on the next slide, but let's just try and highlight what's going on. This 4 to the power of 5, if I was going to write that out the long way, is 4 times 4 times 4 times 4 times 4. Look at them all. There's 5 all lined up. And divided bys, a fraction is a divided by. I'm going to write it as a fraction. I'm getting rid of this, right? So I've got 4 to the power of 5, and I'm dividing away 4 to the power of 2, 4 squared, okay? So what you might remember from studying fractions in previous years, if you've got the same thing on the top of and the bottom of a fraction, you can cancel them out, right? So I can cancel out, say, this 4 with this one, and that one with that one. Right, I'm using the 2 on the bottom to cancel that 2 on the top, and hopefully you can see what I'm left with. I'm left with 1, 2, 3, 4s all being multiplied together. So what I can write that as in the simplified way is it's 4 to the power of 3. Okay, so hopefully you can maybe see the shortcut about how a 5 and a 2 get turned into a 3. Because for some people they find this kind of working out or illustration confusing. If so, just focus on maybe how I can use a 5 and a 2 to make a 3. And we'll go through the explanation right now. All right, so this is your one for your glossary for this second index law. Basically, if I'm dividing and I've got the same base, right, in action, we simplify our work down by just subtracting the powers from each other. Right, that's how a 5 and a 2 get turned into a 3. All right, don't worry so much about all this working out. We don't have time to write this down all the time when we're in the middle of a sum. We should just know that if I have 5 lots of 4 all being times together, then dividing by this means I'm getting rid of 2 of them. So I'm just left with 3 at the end. So let's do a couple of examples of that. Let's start with the number 6. I've got 6 to the power of 5. Why not? And if I divide away 6 to the power of 4, then what this is saying is I've got like this 6 times 6 times 6 times 6 times 6 thing going on. I've got this bunch of 6's all being timesed, and I'm dividing away 4 of those. So all you have to do to simplify that is go 5 take away 4, right, on the power. Right, I had 5 of them. I'm getting rid of 4 of them. That means I've just got 1 of them. And we don't need to write the power of 1 because, well, this is just one lot of 6, isn't it? So same thing with letters. If I have the letter B, I've got 10 of them. And I divide away B to the power of 3. This whole thing is saying I've got 10 B's all being times together, but then I divide away 3 of those B's, then I will have 7 of them left. All right, again, in the glossary underneath the first one. All right, and even though you guys are stuck at home without much help, let's just be good enough to put these couple of ideas together, index law 1 and index law 2 in the same sum. What we've got here is a question involving the base A, and we can do maths with this because it's all the same base, right? These are all about the letter A. A is my base here, here, and here. Index law 1 says if I see a times in between these, I should be putting the powers together because it means I have more A's. And if there's a divided by, I should take the power away because there are less A's. So put the index laws to work. We can start with our power of 7 from the first one. Index law 1 says that I should add this power to get 3 more A's into it. And index law 2 says I should get rid of a couple of A's, okay, from the power. So at the end of the day, the answer is going to be a to the power of something. I've just got to know what 7 plus 3 take away 2 is. So if I start with 7 A's all being times, then I times in 3 more A's, I'm up to 10, and I divide away 2 of those A's, then I'm back to 8. Okay, so we can put these index laws together, and you'll have to as we learn more of them as we go. For now, practice these couple on Google Classroom, and we'll see you Wednesday.